Right now, there is a very good chance that you are walking on literal garbage.
Yeah, expensive garbage, usually.
Right, exactly. You probably paid like well over $100 for the privilege, but it is actually this vital piece of engineering that is helping save the planet. So welcome to the deep dive.
It really is quite the shift in perspective.
Yeah.
Moving from viewing marine waste as this catastrophic final endpoint to suddenly seeing it as a highly valuable premium raw material.
Today, we are digging into a massive dossier on the evolution of sustainable fashion. Specifically, we're looking at high-performance sneakers made from recycled ocean plastic.
Which is such a fascinating market right now.
It really is. And we are examining the role of modern apparel brands, like one in particular called Apparelizer, in driving this entire market shift. Our mission today is to figure out the actual, mechanical alchemy of taking discarded fishing nets and bottles out of the sea and turning them into premium footwear.
Right.
And more importantly, what this rapidly scaling technology means for the future of how you shop, dress, and just live your life.
The transition from pollutant to product is remarkable.
Hmm.
I mean, for decades, the industrial model was entirely linear.
Take, make, dispose.
Exactly. You drill for petroleum, you crack it into polymers at a chemical plant, you manufacture a plastic bottle, it gets used once, thrown away, and eventually a massive portion of it washes into the sea.
Yeah.
We have been conditioned to view that ocean plastic as a permanent tragedy, but the supply chain is fundamentally rewiring itself. It's starting to treat those massive oceanic garbage patches not as landfills, but as resource deposits.
We don't need to spend 20 minutes rehashing how severe the ocean plastic crisis is, right? If
Yeah.
you're listening to this, you already know the stakes.
You've seen the pictures.
Exactly. Millions of tons of waste, marine life entanglement, microplastics infiltrating the food chain. It's a systemic disaster. But looking at this through the lens of resource extraction totally changes the math.
It really does.
Because instead of drilling a new oil well, manufacturers are essentially, dragging a net through the Pacific to harvest their raw materials. It's like this massive untapped mine.
And the brilliance of that specific economic intervention is that it acts as a dual force mechanism.
Okay, how so?
Well, you are physically extracting the legacy pollutant, pulling the discarded nylon nets and bottles out of the fragile coastal ecosystems, but you are simultaneously starving the global demand for virgin plastic.
Right, because if a shoe company buys a ton of recycled ocean plastic, that's a ton of new plastic they don't have to order from a petroleum refinery.
Precisely. And the net energy equation is heavily in favor of the recycled material.
Oh, really?
Yeah, recycling existing polymers requires a fraction of the thermal and electrical energy compared to synthesizing brand new plastics from crude oil.
That makes sense.
So you reduce the carbon footprint and greenhouse gas emissions at the front end of the supply chain while physically remediating the environment at the back end.
Okay, I want to drill down into the actual technology of this, because this isn't just, weaving a bunch of gross, degraded grocery bags together.
No, definitely not.
The materials targeted by these footwear brands are highly specific. We are talking about recycled PET plastic bottles, recovered ghost fishing nets combined with recycled rubber and sustainable foams.
Right.
What is it about PT that makes it the holy grail for a running shoe?
So PET, or polyethylene terephthalate, is a highly durable, lightweight thermoplastic. It's the standard material for most of our beverage bottles.
Like your average water bottle.
Exactly. But at a molecular level, PT has excellent tensile strength and flexibility.
Mm.
When you melt it down and extrude it into fibers, it behaves remarkably like traditional virgin polyester.
Which is everywhere in sportswear.
Right. It's been the absolute backbone of athletic wear for over half a century.
But wait, a plastic bottle that has been floating in the Atlantic Ocean for 3 years isn't exactly pristine.
No, it's in rough shape.
It's bombarded by UV radiation, it's baked by the sun, soaked in corrosive salt, covered in marine growth. How do you take a degraded, brittle polymer and turn it into a high-strength shoe upper without the material just, snapping the second you tie the laces?
That is where the industrial engineering gets incredibly precise. The collection phase, just getting it out of the water, is only the initial hurdle.
Okay.
Once you gather the material, it goes through an aggressive sorting and decontamination process. You have to strip away the biofouling, the salt, the sand.
All the ocean gunk.
Exactly.
Yeah.
But more importantly, you have to isolate the specific polymers. If a recycling facility accidentally mixes PDET with, say, high-density polyethylene or PVC, it completely ruins the structural integrity of the final fiber.
Oh, wow. So how do they separate it?
They use advanced near-infrared lasers.
Lasers.
Yeah, they optically sort the plastics by their specific chemical signatures while they move on a massive conveyor belt.
That is wild. So they are essentially refining it back to a pure base state.
Right.
Then we hit the processing phase, which involves shredding and melting. And this is where I get hung up on the logic a bit.
Okay, how so?
Well, we're talking about reducing our carbon footprint. But we are powering up massive industrial shredders and high heat furnaces to melt down plastic. Doesn't that just, offshore the pollution from the ocean to the factory smokestack?
It's a completely fair pushback and a very common skepticism regarding any recycling initiative.
Right.
You always have to look at the comparative energy cost. The thermal energy required to melt down clean, shredded peat flakes is significantly lower than the extreme heat and pressure required in a petrochemical plant.
To make the new stuff.
Exactly. Cracking crude oil into monomer gases and then polymerizing them into virgin plastic takes a massive amount of energy.
How much lower are we talking? Like, what's the difference?
We are seeing reductions in greenhouse gas emissions that often exceed 50 to 70% compared to virgin production.
Oh, wow. That's huge.
It is. Plus, there is a mechanical advantage to the shredding process itself. By grinding the plastic bottles into tiny flakes first, you dramatically increase the surface area of the material. And increased surface area means it melts much faster and far more uniformly, which means you need even less sustained heat from the furnaces.
That makes total sense. Increased surface area equals faster melt. So once we have this vat of molten, purified ocean plastic, how do we get a thread? Because pouring liquid plastic into a shoe mold gives you a rain boot, not a flexible, breathable running shoe.
Right. Nobody wants to run a 5K in a plastic bucket.
No.
The transformation happens through a process called extrusion. The molten PE is forced under high pressure through a device called a spinneret.
A spinneret, like a spider.
Exactly like that. It is essentially a heavy-duty industrial shower head with microscopic, precision-engineered holes.
Okay.
As the liquid plastic is pushed through those tiny apertures, it immediately cools and solidifies into continuous ultrafine filaments.
Like a pasta maker, but on a microscopic scale.
A highly advanced pasta maker, yes. And the crucial part of that extrusion process is what happens at the molecular level.
What do you mean?
Well, forcing the material through those tiny holes physically aligns the polymer chains along the axis of the fiber.
Oh, interesting.
That alignment restores the immense tensile strength that might have been compromised by UV degradation out in the ocean. You end up with a high-performance yarn that can be spun, dyed, and knitted.
Which brings us directly to the shoe itself. Because having brilliant, newly aligned, recycled fibers is great, but fibers aren't footwear.
No, they're just the raw material.
And historically, eco-friendly fashion meant, stiff, uncomfortable, scratchy fabrics. You wore it to make a statement, but you certainly wouldn't want to run a marathon in it.
Right, it was all hemp and burlap.
Exactly. So if these brands want mass adoption, how are they matching the ergonomics of traditional synthetic polymers?
By completely overhauling the manufacturing process and utilizing advanced 3D knitting technologies.
3D knitting.
Yeah. Historically, making a shoe meant cutting flat panels of fabric and stitching them together. That process creates weak points at the seams.
And a lot of waste, I'd imagine.
Huge amounts of waste. It leaves 20 to 30% of the fabric just sitting on the cutting room floor. Modern sustainable brands program computerized machines to weave the exact shape of the shoe upper in a single continuous piece.
So they can vary the tension and thickness of the recycled yarn throughout the shoe.
Exactly.
Like they can make the heel rigid for ankle support, but keep the toe box incredibly flexible and breathable, all from the exact same thread with zero wasted fabric.
You've got it. And this is where the market dynamics experience a massive shift. You're no longer asking the consumer to compromise on performance for the sake of the environment.
Right.
The durability, the lightweight structure, the moisture-wicking capabilities, they are entirely on par with or even superior to traditional luxury footwear.
You see a brand like Apparelizer heavily pushing this narrative.
Mm-hmm.
They aren't just tucking their recycled shoes in the back corner of the store with a little green leaf sticker.
No.
They are putting them front and center as their flagship technological achievement. It feels very similar to the trajectory of electric cars.
Oh, that's a great comparison.
Yeah, 10 years ago, an EV looked like a weird science project. It was essentially an appliance you bought to signal your environmentalism, but you sacrificed aesthetics and performance.
It wasn't exactly cool.
Right. But today, they are engineered to be the fastest, sleekest, most desirable vehicles on the road. Apparelizer seems to be operating on that exact same logic. If you want to change the world, make the sustainable option the coolest option.
Consumer psychology dictates that altruism alone rarely drives mass market adoption. People fundamentally want a superior product.
Of course.
Apparelizer recognizes that by highlighting the technical innovation, the idea that you are wearing advanced, repurposed marine engineering on your feet, they create a premium narrative.
Yeah, it elevates the product from a basic utility to a piece of modern wearable technology.
And every time someone buys into that premium narrative and purchases a pair, it validates the entire supply chain all the way back to the ocean.
It actively capitalizes
Yeah.
the cleanup effort, right?
Exactly. When consumer demand for recycled ocean plastic surges, the commodity price for that recovered waste increases.
So it actually becomes profitable to clean up the ocean.
Highly profitable. It suddenly makes financial sense for organizations to run massive coastal cleanup operations or to build infrastructure that intercepts waste at river mouths before it ever hits the open ocean.
Wow.
Your purchase at the retail level acts as the primary financial engine for global environmental remediation.
So if you, the listener, are looking at a wall of sneakers and suddenly every single brand is claiming to be ocean friendly because they realize how profitable it is, how do you navigate that?
That's the million-dollar question.
Because that financial incentive you just mentioned also creates a massive incentive for greenwashing. Companies slapping an eco label on a shoe that maybe has 2% recycled content just to capture that premium price tag. What are the actual defense mechanisms against that kind of predatory marketing?
The absolute primary defense against greenwashing is demanding material transparency.
Okay, what does that look like in practice?
A legitimate brand operating in this space will provide specific, auditable data. They won't rely on vague phrasing like made with ocean plastics.
Right.
They will tell you exactly what percentage of the shoe upper is recycled PET, what percentage of the midsole is made from algae-based foam, and they will often partner with strict third-party verification organizations to trace the origin of the plastic from the coastline to the factory.
You have to look past the hero product, too. It's incredibly easy for a massive global conglomerate to produce one single capsule collection of recycled shoes to generate good PR.
While the rest of their business remains unchanged.
Yeah, exactly. While the other 99% of their inventory relies entirely on virgin petroleum and highly exploitative labor practices.
That requires scrutinizing the brand's broader operational footprint. Are they actively transitioning their entire supply chain, or is this just a marketing exercise to distract from otherwise harmful practices? Furthermore, true sustainability encompasses the human element. Brands leading this space are hyper-focused on ethical manufacturing conditions and fair labor practices. An exploitative supply chain inherently contradicts the fundamental principles of a sustainable future.
I've also noticed a heavy emphasis on prioritizing durability and checking real-world customer reviews, which seems obvious for any footwear purchase. But there's a massive paradox buried in this movement that I need you to explain to me.
Okay, let's hear it.
The industry is rapidly moving toward biodegradable components and fully circular manufacturing systems.
Yes, that's a huge focus right now.
But wait, I'm supposed to prioritize a highly durable shoe that won't fall apart and end up in a landfill? How can a shoe be engineered to withstand 1,000 miles of running on hot asphalt, but also be designed to seamlessly biodegrade?
Ah, I see what you're saying.
Like, you can't have a shoe built like a tank that also magically dissolves into the earth.
It is a fascinating tension to spot, and it stems from a widespread public misunderstanding of what words like circular or biodegradable actually mean in an advanced industrial context.
Okay, help me out here.
We tend to conflate biodegradability with basic composting. If you throw an apple core into the woods, naturally occurring microbes break it down in a matter of weeks.
Right, and if my $200 running shoe did that the second I stepped in a muddy puddle, I'd be demanding a refund.
Exactly. So the objective of these brands is absolutely not premature degradation. The goal of a true circular economy is creating a product utilizing highly durable materials that only break down under highly specific, intelligently controlled triggers.
Controlled triggers, like how do you trigger a shoe to break down?
Consider the structural adhesive used to bond the rubber sole to the knitted upper. Historically, cobblers used toxic petrochemical glues that permanently fuse those materials together.
Making recycling virtually impossible.
Because you can't separate the rubber from the fabric exactly. Modern circular engineering utilizes advanced structural adhesives that